Charlie. 11 people. That's good. There's a couple of people missing. And I can also see there's quite a bit of a delay on here. So it's probably about a minute. Okay, half a minute to a minute. Should be okay. Should be able to cope with that. Okay, let's hope we... right, everybody here. Great. Good morning, Amy. Morning, Luke. Yeah, okay. Please bear in mind there's about a minute delay on here. So it might take like if you ask me a question, it would take about a minute for you to hear my answer. So if I see it on here. Okay, we are looking at Unit 309, and it's just 2 more lectures, and then we're done with this unit. This one, which is 3.6, 37, 38, 39, and 310 as a criteria, and then it's just 1 more, and then we've covered the unit. We're just going to go through what you need to do for the assessment and how we're going to do this and so on, and then we're pretty much done with this one. We can concentrate on 315. Okay, let's make a start. So these are the criteria points about potential greenhouse gases generated as a result of food and drink operations. The waste categories generated from food and drink operations. So we're going to look at different types of waste. The process used for waste disposal in the food and drink operations. Some of the stuff we have already covered in 301, and I did a little bit of cheating when I put this presentation together. I used some of the slides from the EPA, from the Environmental Protection Agency from 301. So we're just going to go through them and just remind ourselves of that, and then we can move on. And then the legal requirement of which are related to waste, and then environmental impact of food and drink operations. So that's what we are done. Hi, Callum. Good. I'm just looking at all the controls here. I've got these 3 screens, and they tell me whether everything is going okay. Feels like being in a spaceship, but it seems to be okay at the moment. The stream is going okay. So let's carry on before it crashes. Greenhouse gases. Greenhouse gases is a little bit of my, I don't know, the whole climate change thing. It's a little bit of my pet hate, because I think there's a lot of claims are made which are not justified. That's sort of my thinking. There's a lot of stuff that's being talked about this where personally I can't see scientific foundation to it, and it's almost like a ideology which is sort of pushed down. Anyway, we have to cover it, and we're going to quickly look at what the effect on greenhouse gases is. First of all, it's when foodstuffs get thrown away, it rots. So discarded food rots away, and when food rots, gases are released. Some of the gases are considered to be greenhouse gases, such as methane. There's been the whole idea that the cows or the beef herds in Argentina are responsible for the greenhouse gas because of the amount of methane they release from their rear exhaust, and a lot of talk has been made around that over time. But my concept, and the other one as well, is there's a lot of release of CO2 as well. So when organic material rots or decomposes, it releases a lot of CO2. Now, the thing which people often forget is that the CO2 to start off with is being captured from the atmosphere through vegetation and through plant life and so on. We eat plants. Plants absorb CO2. Our bodies are made up of predominantly of carbons and complex carbons as well, and so we absorb an awful lot of CO2, and then as we eat this, we also use up the energy. We release CO2 with every breath. So still, whatever goes in comes out as well. So for example, the argument was made some time ago, if you run diesel cars on vegetable oil, which is possible if you've got a very old diesel car with an old injector, you can actually run it on vegetable oil. then there's carbon neutrality as well. So whatever carbon is being captured by the plants is then turned into vegetable diesel or diesel made of vegetable oil, and is then released at the end of it. And so the carbon footprint would be de facto zero, because whatever goes in comes out. Yeah. So all you've done is you've taken the energy out of the process and moved your car with that. So that's really where this carbon balance and all this stuff has to be looked at. So basically, food production that's my argument in this whole discussion, is a cycle where chemicals absorbed from the atmosphere, from plant life, from everywhere else, and then they're released back in the atmosphere as the food is eaten and consumed. Then on the other side, there's an argument about greenhouse gases, and that is about the amount of energy which is required to manufacture the food. So the energy used in the manufacturing process, and if you're at Hovis, you've got like a huge amount of energy which you use for the ovens. So this energy obviously has to come from somewhere, and very often it comes through burning coals. And coals is, again, vegetation that's locked up in the lower layers of the ground. Same as oil and or gas, which is locked up lower down. I think some time ago in the 80s, here in Britain, a lot of power plants were converted from burning coals to burning gas, which was considered to be environmentally a little bit more friendly. But still, there are a lot of hydrocarbons which are burned up and which are released, which we've seen in the last presentation. So again, there are greenhouse gases which are released to some extent, because carbons which previously were locked up in the ground are now released and turned back into energy, and obviously that is sort of goes back into the cycle. So that's stuff which wasn't there before, and so there's an argument that it would change potentially the climate to some extent. I've got a couple of slides here, and they're all based on, some concepts, ideas people came up with in some universities about the amount of greenhouse gases which are produced by certain types of food. If you look at the little diagram below, you've got chicken, beverages, cereals, fruits, dairy, red meat, and this is sort of the percentage. Some scholars reckon they're responsible for the greenhouse gases produced within the atmosphere. Okay, I've got a few more slides. We're going to move on. Liters of greenhouse gas emitted per 100 grams of food produced, and it goes to salmon, eggs, chicken, pork, lamb, and beef. Again, greenhouse gases can be the carbons which are used for the energy to put in them. We've got methane as well. We've got when an animal rots, all this is put into this equation, and then we come up with a figure for greenhouse gases. So according to this list, it's eggs and chickens and maybe piggies are the best type of food to eat. Lamb and beef are much more intensive, and probably the argument could be that they produce a lot more methane in the lifespan. Okay, moving on. Greenhouse gas emissions by diet, and I'm not sure how they come up with these figures. I've just been looking around, greenhouse gas emissions and the food industry, and I found these tables. Apparently, vegans produce the least amount of greenhouse gas, and I'm not sure. I eat a lot of meat, so I'm probably one of the biggest culprits, so twice the amount of greenhouse gases than a vegan for me. How many? 100 gram daily. Do I eat 100 gram meat per day? I don't know, maybe. But don't know. Just some figures which they come up, and some universities they spend a lot of money and time to come up with these tables. How true this is, who knows? Okay, methane, sources of greenhouse gases. Methane comes from grazing animals as they digest their food and from decaying matter in wet rice fields. Can also be released from buried waste. Yeah, so that's important as well. When you go to a slaughterhouse, the amount of waste which comes from a slaughterhouse is quite phenomenal. It's not everything of an animal that's produced, and obviously that's put away somewhere and can be released from that as well. Interestingly, coal mining also produces methane, and it's stuff that's also ozone naturally present in the stratosphere. Okay, so that's what we've got up there. The problem is methane attacks ozone. We get holes in the ozone layer, and then it can be quite problematic when ozone is no longer present in the stratosphere. And the reason is ozone absorbs UV light. UV light is highly dangerous for us. So if we get too much exposure to UV light, there's good chances of skin cancer, and also plant life suffers as well and gets damaged by UV light. So UV light is very, very problematic, and the ozone layer hits it. And a few years ago we had this big thing, the hole in the ozone layer, and it was in the southern hemisphere, and they actually had a lot of problems with skin cancer in New Zealand and Australia, and then suddenly the hole closed up again, and predominantly due to the reduction of CFCs, the little gas they use for spray bottles, for hairspray and other spray stuffs, and what they use for fridges as a refrigerant. Again, we looked at this in, I think, in another unit where we covered this. Okay. Eat for the planet, one green planet. We've got another table here. So it's just something to make you aware of. So when you've got the food chain and you produce food, there's a lot of stuff that's being used up. So we've got freshwater supplies which are used to grow livestock. We've got global greenhouse gas emissions produced by livestock, global arable land devoted to livestock feed, and so on. I think the argument they're trying to make here is that meat is really, really bad, but then on the other side, there's a lot of land in the world. If it weren't for meat production, it couldn't be used. So anyway, moving on. We're now looking at food and drink waste categories. So why do we have waste within the food and drink industry? And it's a big question. Some of the waste is quite a lot. When you sort of look at the supply chain, I mean, you're sort of in the middle of the supply chain. So you get your flour, water, if you work for Coca-Cola, and obviously the extracts and so on. And you're sort of in the middle, where a lot of stuff is delivered to you. You put it all together, then it goes to the consumer. So it goes to restaurants, it goes to kitchens, and so on. I've not worked that much in the food industry. I've worked in the sewage plant, and we were at the other end of where waste was coming through to us at the sewage plant from food production industries, and you could tell when the stuff was coming through, especially on a Friday when they were washing everything out, and all the the waste was actually coming to us. And we had a slaughterhouse which was connected, and when I worked on a Saturday morning and they had a big clean out on a Friday afternoon, all the crap really appeared at the sewage plant. So one thing I had to do was just like picking up bits of slaughtered cows and getting them from the inlet, getting them out of the inlet, and throwing them away. Anyway, let's go through the different categories we've got in waste production. So one of them is overproduction. So stuff is produced, food is produced, it cannot be sold in time, the production has been too high, the demand isn't there. So the problem with food is it's only got a limited time span of it being fresh, of it being able to be sold. So if it doesn't get sold within 1 or 2 days, it has to be thrown away. Then we've got wait time, transportation waste, so things go wrong in transportation, processing waste, and processing waste, and then we've got motion and movement waste, inventory waste, and defects waste as well. again, it's just a couple of stories I have on this. There's a jam manufacturer in my hometown called Stute. And if you buy jam or marmalade or something from Aldi, it's most likely being produced with Stute. And I know a lot of people who've worked there. And they, when a truck came in with, for example, with apricots for apricot marmalade or jam, and they got somebody out, and the person had to look at the fruit which was delivered, and if it wasn't up to standard, like if the truck journey from Italy or wherever the fruit was coming from took too long, and some of the food was wasted, then the whole load was condemned. Okay, we've got a couple of questions here. Motion movement waste. Okay, gonna go through this. Anyway, one of the horror stories, which is the everything was condemned, and one horror story I heard was that the truck driver was so annoyed because he had to pick up some other load somewhere else, so he just unloaded the whole stuff, put it on a pile on there in the forecourt. So all these apricots were all over the place, and then he just took off. Yeah. And he thought, it's not my problem. I need to pick up a load somewhere else. I need to get rid of this stuff. You deal with this. The horror story was that whatever he unloaded, obviously the load was rejected, was still put into the manufacturing process. So they took all the apricots, and instead of binning them or throwing them away, they turned it into jam. That's one of the stories I got from this quite a few years ago. It's going about 20 years back. I don't know whether they would get away with that today, but it's quite horrifying. Needless to say that a lot of people who work there don't eat the products, so they don't buy their jam from Aldi's or from wherever it's getting sold. Okay, motion movement waste. Sure. The way I understand it is if you've got a conveyor belt and there's some foodstuffs that's on the conveyor belt, and stuff drops off, or one example I had, and I'm going to talk about the story in a minute, that's about After Eights at Nestle. When they were producing After Eights, they've got to put the little After Eight chocolate bit into the pockets, and it's a very delicate process. And if they don't get it right, the machine is just rejecting it all, and you get like big batches of After Eights which are rejected. So you've got a PLC, so the sensor comes, and it needs to be aligned 100% for the chocolate bit to be pushed into the little paper pocket. And if it doesn't work out, then obviously they can't do it by hand. It's happening really, really fast, so the whole batch gets rejected, and they have to throw it away. That's what I understand would be motion and movement waste within the production process. Okay, thanks for that question, Brad. Right, let's move on to the next slide. 3 types of main food waste, and again, it's just one way of categorizing it. So it's avoidable food waste, and it's potentially avoidable waste and unavoidable waste. So we've got some figures as well, 60, 20, 20. Again, who knows where they get these figures from, but in the West, there's a big sort of thing about that, the amount of food which is wasted in general, that a lot of food that is bought ends up in a cupboard, and then people don't eat it because they don't have a liking for it during the time it's fresh, and then eventually gets thrown away. I think one of the worst culprits is the United States. It's a huge amount of food that gets thrown away in the United States, statistically. Not sure how bad it is here in Britain, but it is an issue. And it's at all levels. So when you look at the food production at the farming level, a lot of stuff gets wasted. When you look within factories, I would imagine it's the same as well. Maybe you can just comment in the chat room how much food is getting wasted in your factory. I mean, how much is it? Is it a little or hardly noticeable, or is it quite significant? Right, just move on. Bearing in mind there's a minute delay, so when you hear this, it's about a minute ago. Okay, we've got a couple of things as well about different types of waste. We've got overproduction. Produce sooner, faster, on greater quantities than customer demand. And that's always a problem, because when it's you produce a certain amount of beer or food or bread or whatever, and then sometimes the demand is very different. I know a few years ago a friend of mine was working at John Smith at the brewery. That's the reason why I was talking about beer. And they had a massive problem with the demand. They couldn't meet the demand. And normally it takes quite a, if you brew beer properly, it takes, or lager, if you brew it properly, it takes a certain amount of time. It needs to sort of mature, and the fermentation has to take place and everything. So what they did is, because the demand was suddenly so high, they lowered the quality of the beer, and they added some chemicals to speed up the fermentation process, to produce twice, even 3 times more than normal, and to get it through the door, so that people would have enough beer to drink in the summer, that there wouldn't be a shortage. Okay. Right, I've just got the chat room here. I think it's enough waste to buy a small car at the end of every shift. Yeah, that wouldn't surprise me. About 2 tons. Yeah, it's a lot of waste, isn't it? And it's probably unavoidable to some extent. But it's also an area where companies can work for, and where the food industry can work for, to minimize waste and to have more profit ultimately through minimizing waste. Okay, number 2, we've got inventory, raw material, work in progress, or finished goods, which is not having value added to it. Yeah. Then 3, waiting, people or parts that wait for a work cycle to be completed. So there's some wastage there. Motion, unnecessary movement of people, parts, and machines within the process. Transportation. Then we've got rework and over-processing. Okay, let's move on. Food recovery hierarchy. So we've got food waste, and we need to try to get rid of the waste, which makes sense as well. One of them is source reduction. So, for example, in Hove's case, it might be produce less stuff, get less flour, less. What else do you put in your bread? I don't fully understand how to make bread. It's flour, water, a couple of other ingredients. Just reduce the ingredients, but there's always an element of risk in there. If you go too far and you play it too tight, if you ever have a sudden demand or a rise in demand, you may not be able to meet it. And maybe it's more important to not have empty shelves than risk having empty shelves in the shops and not being able to meet demand. In Germany, there are a lot of bakeries, and the bakeries are very often tied up with DIY shops for some bizarre things. So you've got a B&Q, and then inside the B&Q, and this is typically for Germany, you would have like a big bakery with lots of cake and bread and things like that. And then also sometimes normal groceries. And I've seen it a bit like with Tesco and Morrison's as well over here, where they've got like the separate bakery. And it's interesting. I've sort of spoken to people who work there, and I know in Germany with these DIY shops. So if a bakery wants to set up a bakery in one of the shops over there, or like in a DIY shop, which I don't know why, but it's some bizarre thing. Is virtually every DIY shop you've got this attached to that, some sort of food supply as well. And maybe people, they buy some cake or whatever when they buy some tools. I don't know where the link is, but it's happening. But the DIY store requires of the bakery to have bread available right to the end of the shift. Yes, even though it's unlikely for anybody to buy this, but it needs to be in show just in case somebody comes in and he wants to buy some of it. And what's happening is that a lot of food gets wasted at the end of the day, because it's unlikely that people will buy a loaf of bread at 5 o'clock in the afternoon or something. This normally happens in the morning. It might happen, but might not. But they are, by contract, obliged to provide, to have this food supply in, or have these products on show till the end of the day, and in case somebody wants it, to be able to sell it to them as well. And so there's already wastage built into the process where the stuff gets just thrown away at the end of the day and is not really used. Yeah, we've got some says you should give it away to the homeless. Can't give away secret recipe. Okay, that's okay. Yeah, and I mean that's the other side which is happening. So you get like food banks opening up. I haven't seen that much here in Britain. In Germany it's quite big at the moment. In America it's very big as well. So restaurants, shops where food is out of date and is normally thrown away, it's collected by food banks and it's given away to needy people. And that's the second point here on the slide as well. Another big thing which happens a lot is feeding animals. And again, coming back to the story from Nestle, the After 8 story, and I'm not sure whether I've mentioned this before, but Ian from work, he's told me what's been happening over there. And apparently, where they had the After 8 production, whenever they had like a big wastage, for example, this scenario where the little After 8 chocolate bit didn't get into the wallet and the machines go really fast and suddenly you've got like half a ton of After 8 waste, which you need to get rid of, where you've got like piles of paper and chocolate bits all over the place. So what they were doing is they were just giving it to farmers. I'm not sure whether they were selling it or giving it to them, but the farmers would just pick it up and feed their pigs with it. And so there was a time when they didn't get it right and pigs were eating an awful lot of After 8 and they probably loved it and it was really great. But the drawback was that the bacon, which was produced from those pigs, was sold at Tesco, I think, or one of those big stores. And customers had a complaint that the bacon tasted minty. And anyway, they didn't know what was going on, but there were quite a few of these complaints coming in, so they were checking it out and went back to the producer, and it was basically those pigs eating After 8, causing the bacon to taste minty or having a minty taste. So, yeah, Brad was just saying we give ours to pigs as well. So anyway, that's another way of doing this. Some pig's idea, pretty much eat anything. Industrial uses, some of the stuff can be possibly recuperated for some raw materials or something else. So we've got waste, for example, methane can be captured and it can be used to heat something. The sewage plant where I worked at, there were the sludge which was coming out, the organic sludge, they were heating it up. The result, the bacterial decay, would cause a lot of methane. The methane was captured and it was used to heat up the sludge and also to heat up all of the sewage plant, all the buildings where people were in. And the rest of the methane was burned off. Yeah. So instead of raw methane going into the atmosphere, it was just burnt off methane, which is a lot less dangerous. Composting as well, and then right at the end is landfill or incineration. Now, incineration is interesting as well. There's a lot of energy in food. When you incinerate it, theoretically you could use it for powering as a power plant or for heating purposes and so on. Okay, move on. Right, we've got, this is all about classification of refuse materials. We've got garbage, which is waste from kitchen, cooking, serving, slaughterhouses. Then we've got combustible and non-combustible rubbish. So some obviously can burn up and and others can't. For example, you've got your packaging for your food. Bottles, for example, plastics and so on. I mean, plastics can burn, I guess, but glass less likely so. We've got ashes, residue from fire, cooking, cinders, etc. So that could be just thrown away. We've got dead animals, construction demolition waste, possibly sludge as well from the sewage system you have. Most companies these days probably have their own sewage plant connected to the plant, so whatever goes out through the water is filtered before it goes to the public sewage plant. Okay, it's just a little bit about just a slide about what you do with the wastage. We've got landfills, composting. We've got wastewater, which needs to be treated, common effluent treatment, which again is done by the town, discharge into water bodies, which is a problem, slightly problematic. In Britain it used to be done an awful lot, that sewage was just pumped into the sea, and I think it's stopped now. I think there's some EU regulation which has come out, and it's required all towns to have their own sewage plants before the water is released into the sea. And I've seen it again, it's going back about 20 odd years, possibly more, about 20 years I think. I've seen it in Bridlington. When you sort of walked away from the main beaches, there was suddenly this brown soup coming up in the middle of the sea, and the weird thing was the currents were sort of driving it towards the beaches where people were bathing, and they probably didn't realize, but it was quite a far way out, and so probably by the time it would hit the beaches it was very much diluted, but that was a real problem. So what's been happening in the meantime is there have been sewage plants coming up all over the place, and so the water that is released into the sea, the wastewater, is being treated and is okay. It's not much of a problem. Anaerobic fermentation happens when stuff is buried. And there used to be a company here in Yorkshire as well, Yorkshire Brick. And they had a deal with the local council, which is in this case is Barnsley, and they picked up all their rubbish, and they were relying that there was a lot of organic rubbish as well. They would bury it, they put a clay layer over it, then they had some pipes into the where the rubbish was placed down, and the pipes would actually pick up anaerobic fermentation, and one of the byproducts is methane, and they use this methanes to burn the kilns. And the story I heard was that they saved, and again it goes quite some time ago, and they saved about £500,000 in gas bills per year through this process, and in addition they could charge the council for taking their rubbish and getting rid of it. And it was even more advantageous. What they were doing is they dug out big holes in the landscape to take the clay out to use them for producing bricks. And so they would have had to fill up those holes anyway, and they just got the rubbish from the council and got money for it. So it was like a win-win process, and it was a very environmental approach all the way through. And at the end they had a product where they were producing these red bricks and made a lot of money. The company doesn't exist anymore, unfortunately. They used to be quite nearby where I live, but they lasted for a long time, and it was like a really, really good concept where an environmental approach was actually making them a lot of money. It's a little bit awkward, but the impact was minimal. Wherever they dug the clay out, a couple of years later there would have been a little forest or some meadows and stuff like that, and people wouldn't even realize that they're just walking on millions of gallons of rubbish. Yeah. Okay, move on. Process used for waste disposal. Industrial waste can only be processed by licensed waste disposal contractors. And that's going back to the EPA, which we did in 301 for Unit 301. A lot of food waste products are resources for farmers. So pig farms, compost, and talked about the minty bacon. Liquid needs to be treated prior to being released to the sewage system. So we've got sewage plants which need to be pretty much in every company now. So I would almost guarantee, bet, whatever, that when you look at Hovis, you look at Princess, you look at Coca-Cola, there's either an agreement for sewage plants or there is there is a sewage plant on site to deal with all the waste that is coming through to start off with, so that whatever water is left in the sewage system is not quite as contaminated as what it could be. Problem is that some waste products are rich in nutrients and can be used for incineration, so that's a good thing. The problem is for sewage, if they are rich in nutrients, they absorb a lot of oxygen. If they absorb a lot of oxygen, it'll fall over. The bacteria which are in the water will fall over and it starts stinking and causes all sorts of problems. Some waste products can be used for biogas production, so that takes place as well. Okay. Right, I'm just going to leave this slide up for a moment. We covered all this before. This is the EPA, the Environmental Protection Act 1990. I'll give you a chance to read through it. And I have a break from talking. Okay. Right. Let me just. Right, let's go through this for a bit. So, number one is there's a duty of care to deal with the rubbish, which is on the company. So, Hovis, Coca-Cola, Princess would have a duty of care with respect to pollution. Makes sense. So, you create rubbish. It's your job to deal with this in the appropriate way. You need to have a licensed carrier. And you need to have proper documentation as well. So that's what has to come from the company. And you have to have consent for discharging waste. And again, when you look at waste products, so they are within the food industry, there's number one, material waste. There's waste, through emissions, sort of burning things, those emissions, smoke. Which may come out, and there's also water as well. So you've got these three areas where waste can be produced, and you need to have consent to discharge those waste in any of these forms. So either through the air, through the water system, or in solid waste. The principle is polluter pays, and if you don't do it, obviously there are penalties and so on in stock. Okay, I'll move on. This is the Environmental Protection Act. This came up in 1990, and there have been revisions throughout the years. One is in 2008. And we've got the fundamental structure and authority for waste management, and we've got control of emissions into the environment. So they are the two big things which have come out of the 2008 revision. We've got, since 1996, we've got for the enforcement, we've got the Environment Agency in England, and in Scotland it's SEPA, and there are criminal sanctions in place. So if you, especially from an industrial perspective, you've got a business and you just throw your rubbish away any old way, there are sanctions in place and you can be prosecuted for it. So the Act looks at controlled waste. It makes clear that there's a duty of care for importers, producers, carriers, keepers, treaters of controlled waste. And obviously the Secretary of State has to create these authorities to deal with that. So that's really what the Act is all talking about. Again, it's just a bit of revision what we did for 301. Local authorities have the following duties: collect controlled waste and undertake recycling, and also there are criminal penalties on households and businesses who fail to cooperate with local authorities' arrangements. It's interesting as well, so they can, I'm not sure how serious it is, and it seems to be different from local authority to local authority. I've never heard anything here in Barnsley that that they've been cracking down on households. And it seems to be that every local authority, they've got different approaches to recycling. I know in Huddersfield, the way recycling happens over there is different to here. Over here, I think we need to have 4 bins or something. We've got a green bin, a blue bin, a brown bin, a grey bin. Green, blue, brown, grey. 4 bins. We've got 4 bins here, which we need to use. And it gets quite confusing at times, you know, what rubbish to put where. Okay, anyway, next. It's just a lot of text here. I'm going to leave it up for a moment. Give you a chance to read through it. I'm just going to read through it myself as well. Okay, it just pretty much is the law text, and it looks at leaving waste unlicensed and so on. So the whole idea is you need to make sure that your waste is dealt with appropriately, and that you use a licensed carrier and not anybody. I think we did some videos, didn't we, with fly tipping and when we did 301 and the stuff that was going on, and what people try to get some of these fly tippers to catch them out and so on. So, bit of a problem. Obviously, within a commercial context, that wouldn't be happening, hopefully. I'll leave it up for a little bit longer, so it gives you a chance to just go through this text. Right, I'll move on. There's a duty of care. Again, it's a lot of text. I'm not going to bother to go through this. Is it the same text? It's not, is it? No, it's not. Anyway, it's just it's to highlight there's a duty of care in respect of waste. And you pretty much don't get away from that. You have to make sure that the right people, the carriers, licensed carriers, pick up on that. Okay. Now we go to the next criteria point: environmental impact of food and drink operations. So the aspects you need to look at is all the way through. You have to imagine, when I look at the Hovis example, you get the food from, or you get the raw products from farmers. The food is transported, or the raw materials are transported. Then there's the actual manufacture of the food products, which takes place. You get energy from the grid. You get ingredients and other raw products from all over the place. You put them all together. You produce your product, your bread in this instance, and then you've got the waste disposal of foods or of things which aren't sold or things which have gone wrong. You may have gases emissions. There may be some liquid waste as well. So you have to clear this up, and then there's a manufacture and disposal of the packaging material as well. When you look at princes, obviously you've got your liquids. So you've got possibly a concentrate for the drinks you produce. You've then got the preforms, the bottles, and I think it's the same probably for Coca-Cola as well. And then you fill up your cans or your bottles, And again, you've got a lot of packaging material as well. So if things go wrong, I've heard in Coca-Cola, if something goes wrong and a line goes wrong, and suddenly all these cans of Coke or whatever, they fly out. The amount of waste that's produced is phenomenal, including the liquid waste and broken cans and so on. So anyway, that's where you get an environmental impact of the food and drink operations. Then on the other end, you've got the consumer side, and it always strikes me when I get my shopping, and you've got lots of plastics around whatever you buy. It could be pasta or cans of food. You would have cans, and it's quite amazing how much packaging is used for the food, and then you look in your bin, and it's full of just lots and lots of stuff. And sometimes you think there's more packaging than actual food you are eating, which you're dealing with. And so again, there's an environmental impact on that as well. I think it was in Unit 3 or 1 where we looked at the plastic waste. I'm not going to go through the whole thing again, but it's just to sort of bring your memory back to what we covered there, where plastics that end up in potentially in the sea or in landfill, and it takes a long time for plastics to disintegrate. Even when they disintegrate, they turn into microplastics, and they don't, down to a molecular level, break down into their original components, but stay the way they are, and then potentially enter the food chain as well, and cause a lot of problems. Right, this is the task, and we are at the end of the presentation. Answer the following questions. I should have put an essay with regards to your place of work. So where the raw materials trace from, where do they come from? What environment impact can you identify from sourcing the main raw materials? Yeah. So I want you to maybe just a couple of bullet points. What you can see, whatever you are producing, what environmental impact have you got for the raw materials? So for Hovis, it would be the flour production, the mill, the farmer, the transporting of the whole stuff. For Coca-Cola and Princess, maybe the obviously the water. Where does the water come from? How is the water processed? So ultimately it comes from a reservoir, then probably Yorkshire Water does some stuff with it to clean it up. I know it goes to Coca-Cola. You take everything out, you filter the water, and then you put your stuff in. So there's that process as well, and there's some sort of impact with that. And then you've got the product which is produced, and it leaves the factory. What waste products can you identify afterwards? So maybe Coca-Cola, you would have your cans, your plastic bottles, for Princess as well. For Hovis, you've got the packaging material, where the bread is put inside. You probably have got crates as well. I'm not sure how bread is shipped, whether it's on wooden crates or whatever, or pallets, whether they're used again or what happens. Yeah. Then also, obviously, bread needs to be baked and put on the counter very, very quickly, put into the shops very quickly. So you've got like a lot of transport routes as well, and I understand that there are lots of factories always has up and down the country to probably cut down on those transport routes, I assume. Yeah. So if you just have a look at that as well and give me some bullet point answers. Comment on the waste products the end consumer will have to deal with using your product. So yeah, what happens when it's all done and dusted, your product is dealt with. So what I want you to do is just think about it, come up with a few bullet points. Doesn't have to be an awful lot. And Gary has asked me that you what I would like you to do is send me an email with your answers, but at the same time, whatever you've written down, upload it to one file as well. I've noticed that some of you have done it, and you emailed to me. Some of you have done it in the answer section of the YouTube video, which is great. Thanks for that. And but if you can get this stuff and just upload it to one file as well, yeah. So as some form of evidence that we've covered this and that you have looked at this as well and did some work on it. Okay, I'm probably going to send an email out with questions for this one and for the other one as well. So you've got it written down somewhere. You can then just copy and paste it into your document and then put some bullet points underneath and then just upload it when you're done. Last slide, discuss what would happen if refuse water containing rich nutrients would be released into the sewage system untreated. Yeah. So again, that would probably affect all of you. Hovis, you've got a lot of flour products. What would happen if you've got water that's enriched with flour and it just goes straight into the sewage system untreated? Coca-Cola, you would have your concentrate. Same with Princess as well. What would happen if it went into the sewage system untreated? Yeah. Just discuss this a little bit, and again, maybe 4 or 5 sentences. I'm not looking for a great dissertation or anything, just a couple of sentences, and please upload it as well. And the summary, that's the end for the presentation. Greenhouse gases are potentially created at every stage of producing and consuming food products. Different categories of waste are produced in the food production process. So we looked at categories. Waste can only be dealt with by authorized and licensed contractors. Very important. Duty of care is with the company. Whoever produces rubbish has got a duty of care to deal with the rubbish, and that has to be done through licensed and authorized contractors or carriers. The EPA, the Environment Protection Agency, is responsible of the legal framework for waste within the food and drinks industry. There's an environmental impact at all stages of the food production process. So hopefully that's what we have shown today. What's the time? It's about 11:30. Just about an hour, despite all the breakdowns, and it worked. The stream kept up all the way through. Right, let me have a look at your comments here. They'll go through bone like butter. Okay, water. It would kill fish, yeah. Yeah, spot on. Clog up the system. Clog up the system as well. It's a big problem, yeah. Remember about the sewage plant? I mean, remember, you wouldn't know this. I've worked there, so I had to deal with that. The way they clean up water is they've got bacteria in the water at the sewage plant, and they actually oxygenate the water to multiply these bacteria. The little bacteria, they eat up all the organic substances, and a byproduct is methane and sludge. So the sludge sinks down and it's pumped off, and the water is relatively clean and so on. So you can imagine when you've got a lot of organic material in the water and there's not enough oxygen, that the bacteria die, and the whole process starts falling down, falling over in cleaning up the water. If you just put this down on paper. Right, we've got a question from Lou. Complete and incomplete combustion equation. If you go down, let me see. I can do it now, can't I? Can I? No, I can't, because it's on. The presentation is on Office 365. I would have to go in there. It would take me ages to do that. Just trying to think. Where have I got this presentation? I can do this on my second computer. Just one moment. Let me just try this. When you go at the last presentation, actually, if you look at the last presentation which we looked at, I'm just going to go in there on my second computer to waste management. Okay, combustion. When you go to combustion, I'm just going to move it forward, and you go to 9 minutes and 48 seconds. You've got the equation for complete and incomplete combustion. So you go to combustion, unit 309 on the YouTube channel, and it's in at 9 minutes and 51 seconds. And you've got both equations for complete and incomplete combustion. That's all it is. Right. That's it. Okay, I'll end the stream in a moment. Any more questions? I think the chat room finishes as soon as I press the end stream button. Okay. Right. I'll the next presentation is going to be at 2 o'clock, and I'll see you there at 2 o'clock. I'm going to send you a link and everything before we make a start anyway. If you miss out the link or the email, just go to the YouTube channel. Everything should be up a little bit before that, so you can then go on it. So otherwise, have a good lunchtime, and try and get these questions answered. I'll send you an email as well with all the questions in case you haven't picked them up from the YouTube presentation. And then please, once you're done, email them to me. A lot of you have done this already, which is great, and thank you very much for that. But also upload them to one file as well, if you can. It doesn't need to be a great thing. It's just like bullet points, for each question, a couple of bullet points, and that's it. Yeah. Okay, thanks a lot. I'll see you later.